Dear students, today we have taken the chapter Units and Measurement. What chapter we have taken, students? Units and Measurement. So let us understand this chapter very properly. So basically, physics is nothing but what? Physics is nothing but it is a quantitative measure of science, right? So quantitative science, which is based on a measurement of what now? Measurement of a physical quantity. Basically, we are going to measure the physical quantities. Okay, so let us understand now. In this chapter, we discuss mainly about what is meant by unit, what is meant by measurement, how to measure a given physical quantity, and how to express it in terms of units that we study. So now here, let's understand about the concept of physical quantity. Now the question will come to mind, what is meant by physical quantity? So physical quantity is the quantity which can be measured either by direct method, or we can say directly or indirectly, or what we call physical quantity. Sir, what is the meaning of directly or indirectly? The best way of telling this directly and indirectly is look at the example around you. There is a table or anything is there. So you want to measure the length of it. Then what you do? You take a scale or the tape and you will put on the scale and use a scale and you will measure it. Means direct method it is. Now, what is the method of indirectly? Now, I want to measure the distance of the moon from the earth now. So, is it possible for me to use a scale to measure from earth to the moon distance? No, right? Not possible, right? So, for these type of things, we are going to adopt a new technique. These are methods are what we call indirect method. There are so many methods are there. Okay, so those we call what indirect methods. That's the reason a physical quantity which can be measured directly or indirectly is what we call physical quantities. There are two types of physical quantities. So let us understand what are those physical quantities. First thing is fundamental physical quantities. Sir, on what basis you are going to divide these quantities? Two type category, either fundamental or derived. So based on whether they are dependent or independent. So on this basis we are going to divide into two categories. One is fundamental physical quantities. What is meant by fundamental physical quantities? These are the quantities which are independent on any other quantities on given place. Wherever you go, whatever you do, okay, so these quantities are independent. So those quantities we call it as fundamental physical quantities. In some books they refer as basic physical quantities. What they call base physical quantities or fundamental physical quantities. So example for this, there are 7 fundamental physical quantities. What are those? First one is mass, length, time, electric current, thermodynamic temperature, amount of a substance, and the last one is luminous intensity. So these are the 7 physical quantities which are independent on any other quantities. Okay, what we call fundamental. Then what is the next type, sir? Next type is derived physical quantities. What are the next type? Next type is derived physical quantities. What is meant by derived physical quantities? The quantities which are dependent on fundamental physical quantities, or we can say base physical quantities. Base physical quantities we call derived physical quantities, or we can say the quantities which are derived from fundamental physical quantities is what we call derived physical quantities. Example for those derived physical quantities: area, volume, velocity. Sir, can you please show us how did we get this area from fundamental? Look at here. If you taken anything, if you taken a small cube, okay, small cube of side is how much now? Side is, let me call A. Then I want to find the area of this. Area is given by what formula? Side into side. The side means length, right? It is length square, means if you multiply length 2 times you get an area. So area we got from length. This is what? Volume, same type. So if I want to find the volume, if I take a cube, then this is also, let me take it as A. Then volume is given by what now? Length cube. So length is what now? Fundamental quantity, right? Yes or no? Length is a fundamental quantity. So if you multiply length 3 times, you get what now? Volume of a given cube. So means which or can be written in the form of what now? Fundamental physical quantities, what we call derived physical quantities. Now we got to know there are two types of physical quantities. One is fundamental physical quantity, one more is what now students? Derived physical quantity. Now we got to know about this, then the question will come to mind, sir, how can we express these quantities? Yes or no? So now we want to express these quantities. To express these quantities, either fundamental physical quantities or what now, or derived physical quantities, we go for a new topic, that is what we call unit. That is what we call students, that is what we call unit. Okay. Now unit means what now? Unit we are using to express physical quantities. So how we are going to express? Let us take now a standard quantity. Let us take any standard quantity. The condition is this standard quantity must be convenient, easily reproducible, and it will be of what now? It will be easily reproducible, must be convenient, small in size, okay, easy to use for all the people. Like that type of quantities, we need to take it as what now? Standard quantity of what now? Of a same kind with which we are going to measure a physical quantity, or we are going to compare with, that is what we call unit. Or you can say simply a standard physical quantity used to measure a given system or given physical quantity of same type is what we call is unit. Now example, now if simply, now you are in the school, if someone asks you how far your school from your home, then you are going to say some 10 kilometer or 15 kilometer, or if you are coming from too far, some 25 kilometer, you say, right? Now example, or else, now there is a notice board in the school or in the college, where what do you want to do? I want to know the size of this notice board. Now I can take anything is standard. Let me take here, there is a signboard or notice board. This is a notice board in your school now or in the college. Now I want to know the length. I will take now standard quantity as a ball. What I take now? A ball. I take ball. I'm going to take as what now? A standard quantity. So this standard quantity I'm going to write now. I'm going to keep the balls here and here now. One ball I'll keep it, and I'll take up. I'll keep it next. 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 Now tell me how many balls I kept now? No, single ball only. Keeping once again, once again, once again, once again, and once again. 1, 2, 3, 4, 5, 6, 7. Okay, 7 balls 7 times I kept. Now see here, one ball I kept how many times? 7 times, to know the length of the notice board. Okay, so now I can say now the length of the notice board is how much? 7 times of a length of each ball. Can we say the length of notice board is how much? Total length. I can say length is equal to 7 times length of, or you can say size of each ball. Yes or no? So 7 times size of each ball, that is equal to given by what now? Give us a total what now? Total length of the notice board, means the what I want to convey here, to express a physical quantity, so we need a unit. So unit must contain two things. One is number. Look at here, there is a number. Yes or no? It is containing what now? A number. And then it is containing what now? What now? How many times it is? 7 times multiplied by each time of the ball. Similarly, if we ask you how far your school is from your home, if you say 10 kilometer, so what are required now? So to express a physical quantity, we need a number and we need a unit. So this is what we call unit, that is standard quantity what we are taken. Okay, means I can say here it is 10 times of each kilometer. Yes or no? So I can say now, look at here. Yes, look at here. I can say what now? Then To express any physical quantity, we need a number as well as what now? Unit. So a physical quantity expression, physical quantity is given by what now? Physical quantity, that is equal to, we can say, number multiplied by unit. So we need a number as well as what and all we need? We need a unit. Yes or no? We need a unit. Number multiplied by what? Unit we require. So if I say the length of the rod is 1 meter, means 1 times of meter. If I say length of the rod is 4 meter, it is 4 times of meter. Yes or no? So meter is a unit what we have taken. So you got to know what is meant by unit now. Unit means nothing but what now? A standard physical quantity. Okay, standard physical quantity or standard quantity what we are using in order to express the same type of physical quantity. You can, why I am telling this again and same kind, because you cannot express the mass using a length. You can express the mass using in terms of mass only, right? The same kind, right? Yes or no? That's the reason. Okay. Now, so I can write now a physical quantity like what now? Like x require number and a equal to u. That is, u is a unit and is a number. So if the same physical quantity can be expressed in different units, yes or no? So in one system I can write physical quantity x is equal to n1 into u1. Example, this only I can say 10 kilometer. I can even say as now 10,000 meter. Both are same thing, right? So because of different units, so I can say now like x equal to n2 into u2. Okay, so one system of unit, other system of unit. Here one thing you can observe, when I convert from one system to other system, look at it from here to here, what happened actually? Check it. Number has increased, yes or no? It was initially 10, now it is 10,000, but unit has decreased, right? Kilometer to meter. So I can say from these two, I can say now n1 u1 equal to what now? n2 u2. So or else I can simply say n is proportional to 1 by u. Means if you increase the number, what will happen to unit? Unit will decrease. Or else if you increase the unit, what will happen to number? Number will decrease. Means the number and unit are inversely proportional to each other. When you increase one quantity, other quantity will become less. So that is what we call unit. So this is the unit. Is clear? It is right. So it is a standard quantity of same kind that we are going to express a physical quantity. To express a physical quantity, we need two things. One, we need a number. One, we need a unit. So number we call n, unit is what we call u. So here, from conversion from here to here, we got to know 10 kilometer to 10,000 meter. We got to know what now? Number is inversely proportional to unit. As we increase the number, what will happen to unit? Unit will decrease. Okay, so this is about the unit of a physical quantity. Okay, so now we got to know when we convert from one number, means one system to other system, number will change, unit will change, and they are inversely proportional. So let us understand about a different system of units. What? Let us understand different system of units now. So here I have taken the first column. They have made 4 columns. In the first column I am going to discuss you what are all different systems we are going to use and how we are going to express them in terms of units. Okay, so basically we have taken only 3 physical quantities here: length, mass and time. So first one is FPS system. So FPS system, in this system, so length is measured in foot, mass is measured in pound and time is measured in seconds. This is the system. Second one is CGS system. In this, length is measured in centimeter, mass is measured in gram and time is measured in seconds. Third one is MKS system. In the system MKS, length is measured in meter, mass is measured in kilogram and time is measured in second. See, in all these 3 systems, common thing is what now? Time. So time we measure in seconds only. Now here, so there is a problem. The problem is, so Some different places they are using some different units. Some places, example, I am using FPS, someone using CGS. Now we both want to design a mission. Then what will happen? The measurement made by me and my friend will be different. Then after that we want to fix the both the instruments. Is it possible? No, not possible. So in order to avoid all these things, we have come up with a standard system, what we call system of international. So what we call system of international. It is just an updated version of what now MKS. Okay, a new version of MKS we can call. Like you can see nowadays there are 4 new versions will come, right? Updated versions, same thing. Okay, so some quantities remain like MKS and some will be updated. That is what we call SI unit, what we call system of international. According to this unit, we adopted some conventions. Means internationally we express length, mass, time, not only these things, all remaining fundamental quantities with proper unit. That is what we call system of international. It is mainly because of what reason? In order to avoid the confusion over the measurements made by different regions. Okay, that's the main thing. So we accepted system of international. According to this, length is measured in meter, mass is measured in kilogram, and time is measured in seconds. Okay, so length, mass, time, 3 are over. There are how many fundamental quantities are there? 7 fundamental quantities are there. So remaining what? We have made a table. I will explain to you there with the help of table. Now let us discuss now. So we have taken different system of units, right? Since there are 2 types of physical quantities exist, then there must be what? No, there must be a 2 types of units. So what are those units? Let us discuss those units now. So what are those units? One is fundamental unit. What are fundamental units? Units we are using for to express the fundamental physical quantities. To express what now? Fundamental physical quantities we call as fundamental units. Example, length. Length we express in meter. Mass. Mass we express in what now? Kg. Next, time. Time we express in second. Next, temperature. Temperature we express in Kelvin. Next, electric current. We express in ampere. Next, temperature is done. So luminous intensity. We express in candela, we indicate CD, candela, and amount of a substance. We express in mole. Okay, especially this amount of substance you deal much in chemistry, more than physics. Okay, there we are going to weigh the given amount of substance to what more, all those things. Okay, so these are what now? These are the fundamental units. What are fundamental units? These are here: meter, kg, second, Kelvin, ampere, candela, and more. These are 7 fundamental units of 7 fundamental physical quantities, or we can say base physical quantities, or we can say what now? Fundamental or base physical quantities. Okay. Now we move on to one more thing, what we call derived units. So as we know already, fundamental derived units are what we call the units of the derived physical quantities are what we call now derived units. Example, you could take area. Okay, so what is the area formula? That is length into breadth. What will be the unit for this? It will be meter square. Okay, force express in Newton. Energy we are going to express in joule. So these are what we call units of derived physical quantity, what we call derived units. Okay, so one thing we want to make it very clear here, the thing is, whenever we express a units, whenever we write a units, there are some rules that we need to follow those rules to express the units, not simply whatever we cannot write like that. So I am going for to give you a hint of how to write the units, especially when you are using a symbols of famous scientists. That's the reason. So now rules for using a symbols in a case of SI system of unit, especially for prefix or suffix. So now let us see one by one. The thing is what now, first one, the rules, the full name of a unit, even if they are named after the scientist, should not be written with initial capital letter. Example. So now what is unit of force? As we know, unit of force is Newton. So unit of force is what now? Newton we know. Now how to write this unit? So you want to write the complete name, you should write what now? Newton. Newton. Not, this is not allowed. This is only allowed. Whenever you are writing a complete name, you should start with seeing small letter only, not the capital letter. But sir, I want to express it in a form of symbol. Then look at here now. The symbols of a unit named after the scientist should have capital letters only. Now this Newton, you want to express means you should express like this Newton. Capital N, not now, not small n. This is not allowed. Okay, if I write another unit, energy unit is what now? Joule. So while writing joule, you should write like Joule. This is the right way, not Joule. This is wrong thing. But while expressing in the symbols, you should write what now? It is joule. Okay, not small j. Then it is valid. It is not valid actually. It is meaningless. It is. Okay, this is a thing you need to remember. Using a scientist name as a unit. So if you are writing a symbol, use a capital letters. If you are writing a complete name, use a small letters. Okay, use complete small letters here like this Newton, or here it is like this joule. Okay, let us see now other one. Next one is what now? Punctuations. Very important here. Punctuations marks are not to be used after the symbol. Example, Newton dot, not allowed. Or I can say Newton dot, not allowed. Just it is what now? Just Newton or just Newton. Punctuations are not allowed. Symbols for units should not take plural form. See here, this is very important. Some people will make many mistakes over here. Some people will write like this. Newtons as what now? NS. Newtons as what now? NS, but it is not allowed. Meters as MS, not allowed. Where especially they will make seconds. They will write what now? Sec, not allowed. Either use second or use complete name. Plural forms are not allowed. That is, when you are writing a units, you should be very careful about these things. Okay, now I am going to show a table. The table containing what now? A different physical quantities, means fundamental physical quantities with their unit, and how to express those physical quantities in terms of what now? Symbols. Okay, we do that one now. Look at here now. So I have taken first fundamental physical quantities. So fundamental physical quantities are what now? Quantities which are independent on any other quantity. This fundamental also called what now? Base physical quantities. What we call, students? Base physical quantities. So now look at the basic quantity. Length. Length we express in meter. Symbolically we represent what now? Meter m. Mass in kilogram we indicate kg. So these are all expression is what now? System of international SI system of unit I am using now. Okay, and in this chapter we are going to follow the same SI system of unit for all the things. Time measured in seconds, symbolically we write S. Electric current, it is CURRENT, expressed in ampere, symbol is A. Thermodynamic temperature with Kelvin, K. Okay, and luminous intensity with candela, expression means how to express this? with the unit of candela we represent CD, small c, small d. And now we go for amount of a substance, we express in mole, symbol is MOL. So these are what now 7 fundamental physical quantities. Along with 7 fundamental physical quantities, there are 2 more are there, what we call supplementary physical quantities. What we call those things? Supplementary physical quantities. What are those supplementary physical quantities? The first one is plane angle. The first one is what now? Plane angle. One more is what we call solid angle. So plane angle means it is going to represent using theta. Okay, it is going to express in theta, and solid angle we represent using omega. Okay, its unit is what now? Radian. Symbolically we write RAD. Unit of a solid angle is steradian. We will write SR. Let us understand these two things a little more. Plane angle and solid angle. So now, as we know already, let us take now. Yes, here let us take now. Let us take now. There is a circular path. There is what now? There is a circular path. So this is the center. The boy is standing over at this point, let me call it, and he moved to where? Here to point B. So now initially he was at here and now he is at here. The angle between these two locations from the center O we express in terms of angle theta. So this angle lie on a where now? Plane. So we call it as plane angle. This plane angle is given by what formula? This plane angle is given by, that is theta is equal to, this is the distance A to B, what we call arc length, divided by, and here this is the radius R from O to A, what we call radius. This is what we call angle theta. Actually, angle theta means what now? It is the arc length by radius vector. For a given figure, it will become what now? Theta equal to AB, that is the arc length, divided by radius is R. Then we want to know the arc length how much? Then arc length become what now? Theta into R. So this is what now? Conversion. And one more thing we need to understand now, steradian. You need to have a little more imagination here. Like what you do, you just form a cone of this shape. Form a cone. So now this cone is going to make some angle, right? Yes sir, this cone is going to make angle here where at this point. There is a circular angle it is going to make. So this area what is covered, let me call this area as dA, a small area, and the distance is what we call here, that is R. So this angle is what we call d omega. Then this d omega is given by dA by R square. That is area which is covered divided by square of the radius is what we call supplementary angle, solid angle. Okay, so just have an imagination, it is 3D picture, this one is 2D picture. Okay, this is plane angle, this is solid angle. Okay, these are very important things, and doesn't have any dimensional formulas. We will discuss later about the dimensional formulas. So this is about fundamental units and the supplementary units of a physical quantities. Okay.